Hello students. Today's topic is control chart U. Control chart for non-conformities or defects. So this control chart U is one of the control chart which is for attribute data and for defects. So there are two types of charts for defects. Control charts for attribute data and charts for defects. So they are of two types. So what are they? The first one, that is A, control charts for number non-conformities or defectives. Control charts for number non-conformities or defects. So we have to remember this is defects, not defectives, and that chart is called as the C chart. The second one is control for fraction non-conformities or defects. Fraction non-conformities or defects. So it is called as the U chart. So now we are going to study about the U chart. U chart and C chart are similar. So U chart and C chart are similar. But in C chart, one item will be inspected for defects. So, but in C chart, one item is inspected for defects. Whereas in U chart, many items in the form of samples are inspected and total number of defects in each sample is found and many samples are taken into consideration. In U chart, many items in the form of samples are inspected and total number of defects in each sample is found. And likewise, many samples are taken into consideration. So the sample size selected may be a constant sample size or a variable sample size. Selected sample size may be a constant sample size and variable sample size. So now let us see how this C chart has to be plotted. What are the things we have to compute and what are the things we have to take into consideration. So here the data for this U chart, that is chart for fraction defect, is shown in this table. So data for U chart, that is fraction defect, is shown in the table. So this data is for sample size which is constant, and this sample size is varying. So here we can see that the subgroup or sample number of items inspected is n, which is same for all the observations till the last one. Here we can see the number of items inspected or the sample size is varying, n1, n2, n3 and so on up to nm. So how to compute the process average, the control limits and drawing of the U chart, revised process average and the control limits. So first we will see how to compute the process average. The first step is computation of process average. So the fraction defective for each sample U can be written as fraction defect for each sample can be written as U is equals to C divided by N. So here we can see that number of defects in the subgroup is given denoted by C. So here it is C1, C2 and C3 and till the last it is CM. Now for the first sample, the value of U1 is C1 by N. This is for the first sample. The second sample, C1 by N1 for the first sample. For the second sample, U2 is equals to C2 by N2. In the same way, the fraction defect for all the other samples are calculated. Similarly, fraction defect for other samples is computed. So fraction defect U will be found as for other samples. For first sample it is U1, for second sample it is U2, for third sample it is U3 and so on up to for mth sample it is UM. So sigma of U is equals to U1 plus U2 plus so on plus UM. So in this way we will find the fraction defect. The next thing which we will find is the process average. So U bar, that is, so process average is denoted as U bar and we write it as sigma of C divided by sigma of N. So that is equal to C1 plus C2 plus so on plus Cm divided by, we have seen that sigma of N is N into M, or we can write it as C1 plus C2 plus so on plus Cm divided by N1 plus N2 plus so on plus Nm. This is for the variable sample size, or we can simply write it as sigma of U divided by M. Now the third one is finding the or calculating the trial control limits or 3 sigma U control limits. So the control limit for U can be given as fraction defect plus or minus 3 into root of U by N. It is the upper control limit for U chart is U bar plus 3 into square root of U bar divided by N, and the lower control limit is U bar minus 3 into root of U bar by N. So this is for constant subgroup or sample size. So this is for constant sample size. Now for variable sample size, the control limits have to be calculated separately because the n value is varying. Variable subgroup or sample size. So control limit for U chart is given by U bar plus or minus 3 into root of U bar by N1. This is for the first sample. In the same way, for the second sample, you can write it as plus or minus 3 into root of U bar by N2. The same way till the last sample, we will write UM is equals to U bar plus or minus 3 into root of U bar by NM. So we will apply plus for the upper control limit and minus for lower control limit for each sample size in the variable sample size. So if the lower control limit is negative, then we should consider it as 0. So plotting of the U chart. So here for constant sample size, see here there is a U chart which is plotted here, and here for variable sample size there is a U chart which is plotted here. For variable sample size, for each sample we will have different UCL, and LCL also will be changing with the sample size. So here there will be a single sample N, and we are marking the U values across the control limits. So if the points are going well outside these limits, then we can say that this process is. So we will explain the analysis of the control chart based on the position of these points. So here in the variable sample size, value of n will be changing for each observation or each point. So even the values of control limit, upper control limit and lower control limit will also vary. So possible charts for fraction defects U chart. So for constant sample size, how do we analyze the data? So here possible charts for fraction defective U chart. So they have given the first two figures, this is A and this is B. So all values or all U values are well within the control limit of U. So here we can see all the values are within the control limit. This is the upper control limit and this is the lower control limit. So we find the values of U in between these two limits. No value is crossing these two limits. So for the first figure A, so if all the points are well within the control limit of U as shown in this figure, then the process is in control and the fraction defect, that is U bar, and the control limit U themselves are revised and recommended that the process average and control limit for future. So if all the points are well within the control limits of U, then the process is in control and U bar and the control limits for U themselves are revised and they are recommended or recommended process average and control limit for future. So they are revised and they are recommended for use in future. Now the second figure B is showing that there are few points which are crossing the lower control limit. It indicates an improvement in the process and they should be identified and adapted in the process to improve the further quality. So here we see that there are points which are below this lower control limits. So the process has to be improved and we have to identify the causes for such points which are going below the lower control limit and we have to adopt the improvement in the process for further quality improvement. Here also the U bar, that is fraction defect, and the control limits are themselves revised or they are recommended process average and control limit for future. Now from figure C we see that there are points which are going beyond the or above the upper control limit. So if the points are crossing the upper control limit, it indicates that there are assignable causes present and the process is not in control. So if there are points which are going above the upper control limit, it will indicate assignable causes of variation in the process and this process is not under control. So in such situation, the U value should be homogenized as described to find the revised or recommended process average, that is U, and control limits for future. So from figure C, points crossing the upper control limit indicate presence of assignable causes of variation and the process is not under control. So in this situation, the U value must be homogenized to find the revised or recommended process average and control charts or control limits for future. The next figure, figure D, is showing that points are crossing both the upper control limit and lower control limit. It is indicating that there is presence of assignable causes for variation as well as there is a requirement for improvement in the process. So here we can see the points are crossing the upper control limit as well as the lower control limit. So but we can see that the whole process is not under control. So in such situation, to revise or recommend process average and control limits for future, the U value should be homogenized by eliminating only the points which are crossing the upper control limit. So in this way we can eliminate the presence of assignable causes. Now let us discuss the control chart for variable sample size. So in this, that is the U charts for variable sample size. See, for each and every sample, that is N1, N2 and so on, as the sample sizes are varying here, we will have upper control limit 1, upper control limit 2, upper control limit 3 and so on till the end. So in this way, these upper control limits are plotted on the graph like this. So this is the upper control limit 1, this is upper control limit 2, this is 3, and this way till the end we are plotting this upper control limits for each and every sample. Now the U values are found differently. So the U values or the points are marked on the table or marked on the chart. Here we can see that the U values for these corresponding sample sizes, that is U1, U2, U3, are within the control limit. So here the lower control limit also for each sample size it will be different. So here these U values are within this two control limits. They are not going beyond the control limit. So from figure A, all the points are well within the control limit of their corresponding sample sizes. Sample sizes or subgroup. From the figure B, we can see that a few U values are crossing the lower control limit. So here this is the mark for the lower control limit, which is given by a dotted line. So this lower control limit is for different type of sample size. Now the U value for that corresponding sample size, here U2 we can see that it is below the control limit, that is the lower control limit, and also U6 is also below the lower control limit. So this indicates that the process is no doubt in control, but this indicates improvement in the process. So a few points or U values are crossing the lower control limit of the corresponding subgroup or sample size. The process is still under control, but it indicates that improvement is required in the process. From these two figures, that is figure C, we can see that a few values or few U values are crossing the upper control limit of the corresponding subgroup, which indicates presence of assignable causes of variation, and because of this, this process is not under control. So here for that corresponding point, that is for that corresponding subgroup, that is 3, the U value is crossing the upper control limit. So this upper control limit for the third sample, we can see that the U value is above this control limit, as well as the U4, that is the value of u for the fourth sample is also crossing the upper control limit. So we can say a few u values are crossing the UCL u of the corresponding subgroup. So this indicates presence of assignable causes of variation, and due to presence of assignable causes of variation, the process is out of control. The next figure D indicates that few values are crossing the upper control limit and lower control limit of the corresponding subgroup. So this is indicating that there is presence of assignable causes of variation, and due to this the process is not in control, and also there is a requirement for improvement in the process. So a few u values. So here we can see, if this is the upper control limit, we can see u value has crossed the upper control limit, and here two values are crossing the lower control limit. The process is out of control or not in control. So this is all about the U chart. I hope you have understood the topic. Thank you.